Hello, today we will study Chapter 15, Multiple Regression Model Part 1, the model. Let us first review the simple linear regression model from Chapter 14. The population model has the form y equals to beta 0 plus beta 1x plus epsilon. By taking the expected value of y, we obtain the population equation showing the linear relationship between x and y. That is, the expected value of y equals to beta 0 plus beta 1x. Now, from the sample model, we have this prediction equation or regression equation y hat equals to b0 plus b1x, where b0 is the y-intercept, b1 is the slope. In here, take a sample of size n. The paired observation SI, YI with I equals to 1 to n, we will have this plot. You plot your data into this XY coordinate system, and then you find this line going through all your data set, and we will be able to get this prediction equation y hat equals to b0 plus b1x. In this chapter, chapter 15, we are interested in developing a model with more than one independent variable. Say we have p independent variables, x1, x2, all the way to xp. And this is called the multiple regression model. The multiple regression model describes the relationship between one dependent variable y and two or more independent variables x1, x2, all the way to xp in a linear function. Again, p is the number of independent variables. Say we have p equals to 2, then the equation will be y equal to beta 0 plus beta 1 times x1 plus beta 2 times s2 plus epsilon. And in this case, s1, s2 are the independent variable and y is the dependent variable. Now, in general, the population model will have y equals to beta 0 plus beta 1 x1 plus beta 2 s2 plus beta 3 s3 all the way to beta p xp plus epsilon. Again, p is the number of independent variables. By taking an expected value of y, we can get rid of this epsilon and to obtain this multiple regression equation. The expected value of y equals to beta 0 plus beta 1 times x1 plus beta 2 times x2 plus all the way to beta p times sp. This is the population model. Now, for the sample model, the prediction equation or estimated multiple linear regression equation is given by equation 15.3. Y hat equals to b0 plus b1 times x1 plus b2 times s2 all the way to bp times sp. And here's the table for getting our data. So you have observations 1 all the way to n, and then you have S1, S2 all the way to SP. Again, P is the number of independent variables, and then we have dependent variable y. And for this equation 15.3, B0, B1 all the way to BP are the regression coefficients. In particular, B0 is the y-intercept, and B1, B2 all the way to BP are the slopes. And there are two very important notes. Note number 1, B0, B1 all the way to BP are the point estimate of beta 0, beta 1 all the way to beta P. 2, the least square method is used to minimize the sum of the square, so the sum of yi minus yi hat square for the ith observation to provide us the values of B0, B1 all the way to BP. We can use this sum of yi minus yi hat square equals to sum of yi minus, this is yi hat from equation 15.3, this is B0 plus B1 times S1 plus B2 times S2 all the way to BP times SP. Next, we will study the interpretation of the regression coefficient. The y-intercept B0. B0 is the estimated average value of y when all the independent variables satisfy this equation S1 equals to S2 all the way to SP equals to 0. i.e., we set all the independent variable equals to 0 to find the y-intercept. And for the slope, bi and I equals to 1, 2 all the way to p. The slope estimate the average value of y changes by bi for each 1 unit increase in xi, holding constant the effect of all other independent variables. And the statement holding constant the effect of all other independent variables is very important since we have more than one independent variables. The application for this chapter will be giving an Excel computer output, and we need to answer some questions. And let us look at this example. Example number 1. To study the relationship among the number of Omni power bars sold in a month, the price of the Omni power bar, and the monthly promotion fee. 34 stores were randomly selected and resulting in the following computer output of the multiple regression model. So here's how we record our data. So we have 34 observations, and X1 is the price unit is in cents. S2 is the promotion fee unit in dollar. Y is the sales, is the dependent variable. And we enter our data into Excel worksheet and generate the computer output of the multiple regression model in this table. So we have the intercept, the price, and the promotion fee. And we have the coefficient, standard error, t-test, p-value. So this coefficient will give us B0 equals to 5,837.52 and B1 to be negative 53.22 and B2 equals to 3.61. We also have this standard error or standard deviation for the intercept, for the price, and for the promotion fee. So this is SB0, and this is SB1, and this is SB2. Now this t-test and this p-value from the table actually is our test statistic and the p-value of the hypothesis testing. And this is for the y-intercept, and this is for the price, and negative 7.77. This is our test statistic, and this is the p-value for the price. And then you have the promotion fee, and this is the test statistic, and this is the p-value. We're going to study this in chapter 15, part 2. Now, let us answer some questions related to the multiple regression model from our Excel output. What is the value of P? Keep in mind, P is the number of independent variables. So in this case, we have x1 and x2. P is 2. Now, what is the prediction equation? So we have two independent variables. There is y hat equal to b0 plus b1 times x1 plus b2 times s2. In this case, the prediction equation will be y hat equals to 5,837.52 minus 53.22 times x1 plus 3.61 times s2. C. Interpret the meaning of B1. So B1 is our slope associated with S1. In this case, is negative 53.22. So we have this equation for each 1 cent increase in the price. Keep in mind, the unit for x1 is in cent. The average number of omnibar power bars sold decreased by 53.22 per month, holding the effect of the promotion fee constant. And this statement is very, very important because we have two independent variables. Now, D. Interpret the meaning of B2. B2 is equal to 3.61, which is positive. So for each dollar increase in the promotion fee, the average number of bars sold decreased by 3.61 per month, holding the effect of the price constant. Again, we have two independent variables. So this statement, holding the effect of the price constant, is very, very important. D. Predict the average value of the candy bar sold for a store that has a sales price of 79 cents and the promotion fee of 400. So we first find the value for x1 and then we find the value for x2. So for the equation, when x1 occur, we use 79, and when x2 occur, we use 400. And keep in mind, the unit for S1 is in cents. So we need to use 79 instead of 0.79. Okay? So now to compute this predicted value, then y hat is equal to 5,837.52 minus 53.22 times 79 plus 3.61 times 400 to get this 3,077.14. So a store that had a sales price of 79 cents and the promotion fee of 400 will sell the number of candy bar sold in this store will be 3,077.14. The last topic for today is the multiple coefficient of determination. Multiple coefficient of determination measures the proportion of total variation in y that is explained by all independent variables S1, S2, all the way to SP. And we use this equation 15.8 to compute the multiple coefficient of determination. So this R squared is equal to SSR over SST. And this equation 15.9 is the adjusted multiple coefficient of determination, and we use this RA squared equals to 1 minus 1 minus R squared times N minus 1 over N minus P minus 1. And this calculation, we also consider the number of independent variable P as well as the sample size N. Now, let's see this example from example number 1. From a computer output, we find out that R squared equals to 0.7577. Interpret this result. So based on this multiple coefficient determination definition, we will say 75.77% of the variation in sales can be explained by the variation in the price and the variation in the promotion fee. And this is an OK model. Only 24.23% of the variation is unexplained.